In this lesson, we'll discuss some terminology that we use when we talk about angles. The first concept is of vertical angles. When two lines intersect, two pairs of vertical angles are formed. Let's look at a picture of this. Now, here we have our two lines. They intersect to form four angles. Notice angle W and angle Y. That is one pair of vertical angles. Can you see that they're equal? Angle W equals angle Y. The second pair of vertical angles formed here would be angle X and angle Z. Angle X equals angle Z because vertical angles have the same measure. Now, when three lines intersect, particularly when we have two parallel lines, and remember that parallel lines are lines that lie in the same plane and do not intersect. When a line intersects two parallel lines, and see here I've got my two parallel lines, and here's that intersecting line, this line is called a transversal. Do you see the 8 angles that are formed? Well, these angles have special relationships. Let's look at those relationships. The first relationship is what we call alternate interior angles. And alternate interior angles are equal. And these are angles on opposite sides of the transversal between the two parallel lines. So let's see here. Do you see angle 3 and angle 6? One is on the left of the transversal, the other is on the right of the transversal. That's what we mean by opposite sides. Do you see that in this case, that here are your parallel lines, and 3 and 6 are both inside those parallel lines? They're between those parallel lines. They are alternate interior angles, and consequently, angle 3 equals angle 6. We have one more pair of alternate interior angles. That would be angle 5 and angle 4. These angles are on opposite sides of the transversal, and they are between those two parallel lines. So angle 5 equals angle 4. Now, another special relationship is the alternate exterior angles. Alternate exterior angles are also equal. These are angles on opposite sides of the transversal, but they are outside of the parallel lines. So one pair of alternate exterior angles would be angle 1 and angle 8. Angle 1 equals angle 8 because they are alternate exterior angles. Notice that they are on opposite sides of the transversal and they are outside the parallel lines. This one's outside of this parallel line, and 8 is outside of this parallel line. Also, we have angle 2 that is equal to angle 7. That's the other pair of alternate exterior angles. Also, we have corresponding angles are equal. Now, I don't have a really good definition of corresponding angles, so just look at this. Angle 1, it corresponds to angle 5. Consequently, angle 1 equals angle 5. Now, notice that angle 1 and angle 5 are both on the left side of the transversal, and they are both right above their parallel lines. Angle 2 and angle 6 are also corresponding angles. Notice that angle 2 and angle 6 are both on the right side of the transversal, and they're both above the parallel line. Now for angle 3 and angle 7, they are corresponding angles, and they are equal. Notice 3 and 7 are both on the left side of the transversal, and in each case 3 is below this parallel line, 7 is below this parallel line. And the last pair of corresponding angles formed would be angle 4 and angle 8. Angle 4 equals angle 8, and notice on 4 and 8 that 4 and 8 are both on the right side of the transversal, and 4's below the parallel line, 8's below the parallel line. Now the last angle relationships that we should know formed by parallel lines in a transversal, we don't give a special name to these angles, but we should know this relationship. Interior angles on the same side of a transversal add to 180 degrees. Now, interior angles would mean inside the parallel lines and on the same side of the transversal. So angle 4 and angle 6, do you see that angle 4 and angle 6 are inside the parallel lines, and they are both on the right side of the transversal? So angle 4 plus angle 6 equals 180 degrees. Angle 3 plus angle 5 will also equal 180 degrees because they are both on the left side of the transversal, and they are interior angles because they are inside the parallel lines. What other name could we give angle 4 and angle 6? Since their sum is 180, what kind of angles do we know that those angles are? They are supplementary, aren't they? And angle 3 and angle 5 are supplementary because two angles whose sum is 180 degrees are supplementary angles. Now, when we have a triangle, we should know that the sum of the measures of the angles of any triangle is 180 degrees. We classify triangles according to the types of angles that they have and according to the relationship of their sides. So let's look at these classifications. We'll look first at by angles. This first triangle would be an acute triangle, and we call it an acute triangle because all the angles are acute angles. Do you remember what an acute angle is? It's an angle that measures between 0 and 90 degrees. This second triangle we call a right triangle, and that's because it has one right angle. Remember, this is the symbol for the right angle. And this third triangle is called an obtuse triangle because it has one obtuse angle. Remember what an obtuse angle is? It's an angle that measures between 90 degrees and 180 degrees. Which of those angles is an obtuse angle? It's this angle right here, isn't it? Okay. When we classify by sides, this first triangle is what we call an equilateral triangle because all three of the sides are equal. Do you notice something else? All three of the sides are equal, but also all three of the angles would be equal. And what would they equal if the sum of these angles is 180 degrees? Well, take 180 and divide by 3. Each of those angles would be 60 degrees. This next triangle is an isosceles triangle, and it's called an isosceles triangle because it has two equal sides. Now, sometimes to show the two equal sides, we put a little mark like that, and that's to tell us that this side equals this side. And also on the equilateral, we could have, and that would tell us that those three sides are equal. On the scaling triangle, it's a scaling triangle because none of its sides are equal. If we wanted to show that none of these are equal, we could put 1 mark, 2 marks, and then 3 marks, and that would mean that each of those measures a different length. The next triangle relationship that we should understand is congruent triangles. Congruent triangles are triangles that are both the same size and the same shape. Do those look like they're the same size and the same shape? In trig, you'll find that we work a lot with similar triangles. Similar triangles are triangles that are exactly the same shape, but not necessarily the same size. And hopefully you can see that I've got two triangles that are the same shape, but obviously they are different sizes. In trig, it's not unusual for us to work problems that require us to understand the relationship in the angles and sides of similar triangles. So let's look at that relationship. In order for triangles to be similar, their corresponding angles must have the same measure, and their corresponding sides must be proportional. Those ratios must be equal. Now, if you notice, I have here two similar triangles. I have labeled the angles with capital letters, angle A, B, C, D, E, F. I have labeled the sides opposite or across from the angles with the lowercase letters. Side A is across from angle A, side C across from angle C, and side B across from angle B, and the same over here. I have also put arcs on the angles. Angle A corresponds to angle D. They are equal, and we know that because they each have one arc. That's how we show that. Angle B corresponds to angle E, and to show that they are equal, I have the two arcs. And I don't have arcs on C and F. They are corresponding angles, but anytime that this angle equals this angle and this angle equals this angle, then this third angle must equal to that third angle. So we can assume that those are equal. Now, for corresponding sides, side C corresponds to side F, and the reason is because side C in the first triangle connects angle A and angle B. Side F in the second triangle connects angle D and angle E, and these are corresponding because angle A and angle D are corresponding, and angle B and angle E are corresponding, so the sides that connect those will be corresponding sides. Side A corresponds to side D, side B corresponds to side E. And when we say those ratios are equal, what we mean is if we take side C and divide it by side F, if we write it as a ratio, C over F, it will equal what we get when we take the length of side A and divide it by the length of side D, which will also equal what we get when we take the length of side B and divide it by its corresponding side, side E. C is to F as A is to D as B is to E. Now that we understand all those angle relationships, let's work some problems. The first one says use the properties of angle measures to find the measure of each angle. Well, in this case, we know that this angle and this angle are vertical angles, and the relationship is that they are equal. So what we will do is we will say 2x minus 5 equals x plus 22. We have a linear equation. Let's subtract x from both sides. Let's add 5 to both sides. 2x subtract x gives us x. Those add to 0. Those add to 0. And 22 plus 5 gives us 27. So we know x is 27. Now it asks us to find the measure of the angle. So we could substitute into either one of these. I think I'll substitute into x plus 22. That would be 27 plus 22, which would give us 49 degrees. So I know each of these angles measures 49 degrees. Now, let's go ahead and find these angles. That is another pair of vertical angles. Now I know that this angle is 49 and I know that this angle is 49. How could I find this angle? Well, look at this. Do you see that this angle plus this angle form a straight angle? Don't we know that a straight angle measures 180 degrees? So this angle would equal to 180 minus 49, wouldn't it? So let's subtract that. 9 from 10 would give us 1. 4 from 7 would give us 3. 0 from 1 would give us 1. So this angle measures 131 degrees, and because this angle is vertical to that angle, it will also measure 131 degrees. For problem number 2, we have two parallel lines and we have a third line that intersects them, which would be a transversal. And it asks us to use the properties of angle measures to find the measure of each angle, and it tells us that line M and line N are parallel. So we'll find all 8 angles. Remember that when a transversal intersects two parallel lines, we have 8 angles formed. We'll start first with this angle and this angle. Do you know what type of angles those are and what their relationship is? These 2 angles are what we call alternate exterior angles. Notice, here's my transversal. This angle and this angle are on opposite sides of the transversal, and for my parallel lines, this angle is outside the parallel line and this angle is outside the parallel line. So these would be alternate exterior angles, and we know that alternate exterior angles are equal. So we'll say 5x subtract 2 equals 10x subtract 32. So we have a linear equation. Let's subtract 5x from both sides. Let's add 32 to both sides. We get 0x minus 2 plus 32 will give us 30. 10x subtract 5x will give us 5x, and those add to 0. To finish solving the equation, let's divide both sides by 5. 30 divided by 5 gives us 6, and of course we get that x is equal to 6. Now notice it didn't ask us to find x, it asked us to find the measure of the angles. So for this angle, I think I'll work with this one. We know that they're equal, so I could find either one. Let's say 5 times 6 subtract 2, so that would be 30, subtract 2 would be 28. So I know this angle's 28 degrees and this angle's 28 degrees. We could check that. 6 times 10 is 60, and 60 subtract 32 sure enough is 28. Now I want to find all the other angles, and let's see how we can do that. Do you see that this angle is a vertical angle for this angle? Two intersecting lines. So if this angle is 28 degrees, what do I know this angle is? It's 28 degrees also, isn't it? And do you see that this angle is vertical to this angle? So if this angle is 28 degrees, this angle will also be 28 degrees. And notice these two angles. They are on opposite sides of this transversal. They are both inside those parallel lines, so they would be alternate interior, and by alternate interior angles, we know that they are equal. Now we need to figure out what these other angles are, and how could we do that? Well, there are several different ways we could do that, but notice that this angle plus this angle form a straight angle, and so the 28 degrees plus this angle would equal to 180 degrees, and so to figure out what this angle is, I could say 180 degrees subtract 28 degrees. So let's see, 8 from 10 leaves us with 2, 2 from 7 leaves us with 5, and so we'll have 152 degrees. So this angle is 152 degrees. Likewise, this angle, because it's vertical to that angle, would be 152 degrees. And what about these two angles? Well, what do we know? We know that this angle and this angle are alternate exterior angles, don't we? They are on opposite sides of the transversal. They are both outside those parallel lines, so they have to be equal. And if this angle is 152, then this angle right there is also 152. So I know it looks kind of messy here. Be sure that you understand that this angle's 28, this one's 152, 28, 152, and likewise down here, 28, 152, 28, 152. Now let's look at a problem that requires us to know the sum of the angles in a triangle. The measures of two angles of a triangle are given. Find the measure of the third angle. Well, since we know that the sum of the three angles in a triangle is 180 degrees, what we will do is add these two angles together and subtract that sum from 180 degrees. When we add, we get 40 plus 50 is 90, 2 plus 4 is 6, 3 plus 2 is 5, we get 100. So when we add those two angles, we get 156 degrees, 90 minutes. We will rewrite that, since the 90 minutes is 60 minutes plus 30 minutes, and 60 minutes is 1 degree, plus the 30 minutes. we'll write this as 156 degrees plus the 1 degree would give us 157 degrees, 30 minutes. Now we will subtract that from 180 degrees. To do that, we'll write the 180 degrees as 179 degrees, and we'll write that other degree as 60 minutes. "30 from 60 gives us 30. 7 from 9 gives us 2. 5 from 7 gives us 2. So that third angle in that triangle would measure 22 degrees, 30 minutes. If we wanted to check that, what we would do would be we would add these three angles together, and that sum should give us 180 degrees. For the fourth problem, we're asked to classify each triangle by its angles as acute, right, or obtuse, and then by its sides as equilateral, isosceles, or scalene. For this first triangle, because it obviously has a right angle, we'll call it a right triangle. For the second triangle, each of the angles is less than 90 degrees, so it is an acute triangle. And for the third triangle, we have an angle that is obviously larger than 90 degrees, so this would be an obtuse triangle. Now, looking at their sides, on this first triangle, we can see we have 1 mark, 2 marks, and 3 marks on this third side, which means that all three of these sides measure different lengths. And when all three sides measure different lengths, we call it a scalene triangle. For this middle triangle, we have 1 single mark on each side, which means all three sides measure the same length, so we call that an equilateral triangle. And for the last triangle, when we mark this side and this side with the 1 mark, that means that this side equals that side, and when we have 2 equal sides, we label it an isosceles triangle. For problem 5, we are to find all unknown angles in the pair of similar triangles. So since they're similar triangles, we know that corresponding angles are equal. So let's see here. This angle right here measures 45 degrees. I was really supposed to write it in there, but it would have been so small you couldn't have read it. So I put it to the side. This angle E measures 30 degrees. Because I have the 2 arc marks by angle A and the 2 arc marks on angle D, that means they are equal, and they consequently are corresponding angles since they are equal. So angle D equals 45 degrees. Because there's a single arc mark on angle B and a single arc mark on angle E, that indicates that they are equal, and they would be corresponding angles for these similar triangles. So angle B equals 30 degrees. Now, last I need to find angle C and angle F. Well, they are corresponding angles, so they will be equal. Let's see, I know I'm going to work with the larger triangle. I know E is 30, I know D is 45. So to find F, I will add the 30 to the 45. When I add, I get 75. And then since I know the sum of the three angles in a triangle is 180 degrees, I will subtract the 75 degrees from 180 degrees. 5 from 10 gives me 5. 7 from 7 gives me 0. And then I'll have a 1. So angle F equals 105 degrees, and its corresponding angle, angle C, would also equal 105 degrees. Let's look at another similar triangle problem. It says find the unknown side length in the pair of similar triangles. Because they are similar triangles, we know that corresponding sides are proportional. So we will set up a proportion. We know that this angle corresponds to that angle, which means that the 4 will correspond to the 12 and the A will correspond to the 9. So we need to find the length of the A. So we will do that by setting up a proportion. We will say that the ratio of 9 to A equals the ratio of 12 to 4. Now notice it's very important, since I use the 9 in the numerator here from the larger triangle, that I also use the 12 on the other side in the numerator, and that the A comes from the smaller triangle and it's in the denominator, and the 4 in the denominator on the other side of the proportion also comes from the smaller triangle. So for my proportion, I know that to solve my proportion that I can cross multiply. Another thing that you may remember is that there are several other equivalent ways to set up a proportion. So if you chose to set it up in a different way, you should come out with the same answer. Let's go ahead and cross multiply. We know for a proportion that the extremes, the product of the extremes equals the product of the means. So we can say 9 times 4 equals A times 12. So we'll get 36 equals 12A, and we'll divide both sides by 12. 36 divided by 12 gives us 3, and so we get that the length of side A is 3 units. In problem 7, we are asked to find the unknown side lengths in the pair of similar triangles. So once again, we have similar triangles. We know that corresponding sides are proportional, so we need to figure out which sides are corresponding, and then we will need to set up our proportions. Now notice these are both right triangles, but don't let it throw you off that this one is turned a different way from this one. We could easily turn this triangle around, and when we did, it would look something like that. So if you're uncomfortable with it turned that way, then flip it over. The side across from the right angle measures 10, this bottom side measures 6, and of course this side measures 8. And it may be easier for you to identify in that case that the 35 corresponds to the 10, that the B corresponds to the 8, and that the A corresponds to the 6. So when we set up a proportion, we will say that 35 is to 10, its corresponding side. Notice the side from the large triangle is to the side from the small triangle, as B is to 8. Once again, since it is a proportion, we can cross multiply, but before I cross multiply, when I can reduce, usually I will reduce. 5 divides into 35 7 times, and 5 divides into 10 twice. So 7/2 is the same number or ratio as the 35 tenths. 35 is to 10 as 7 is to 2. And I think that'll be a little easier to work with. We'll cross multiply. The 7 times 8 gives us 56. And that equals 2 times b, which is 2b. When we divide both sides by 2, we'll get that b is equal to 56 divided by 2 is 28. To find the a, we will go back and use the two given sides. 35 is to 10, and in this case it will be as a is to 6. Now, once again, I would reduce the 35 tenths. I would use the 7/2. And then when I cross multiply, 7 times 6 equals 42. 2 times a is 2a. We can divide both sides by 2, and we get that a equals 21. So the measure of side B is 28, and the measure of side A is 21. Let's look at another similar triangle problem. In the diagram, there are two similar triangles. Find the unknown measurement. Well, the unknown measurement here is side B, and that is this length right here. Now, my first question to you is, where are the two similar triangles? Which triangles are similar here? And it's real important that you understand that you've got this inside triangle and this outside triangle. And I like to separate these. I think sometimes it's easier to see. So what I've got over here is this outside triangle. Now let's label this outside triangle. For this outside triangle, this side length is B, and what's the bottom length here? This means 5 plus 55, which would give us a length of 60. Now, look at the second triangle, which would be this, what I call the inside triangle, which is a little smaller, and I have it labeled right there, or I have it drawn. Let's label it. What we know about the bottom side of this inside triangle is that its bottom length is 55, and then this length, what these brackets mean that extend from here to here, is that this length is 60. Now, since we know they're similar triangles, we know that the ratios of corresponding sides are proportional, so we will set up the proportion. When we draw it like this, can you see that side B corresponds with the side 60, and that the side 60 in this larger triangle corresponds with the side 55 in the smaller triangle? So when we set up our proportion, we will write B is to 60, this B is to this 60, as this 60 is to this 55. We'll cross multiply. B times 55 is 55B. 60 times 60. So 55B equals 60 times 60 is 3,600. To solve for B, let's divide by 55. And that does not divide evenly, so we'll divide that on our calculator. And when we do that, we'll need to round it off, and let's see, since this 55 is two significant digits, we'll round to two significant digits. I get 65.454545. I have a repeating decimal, so rounded, and since we're going to round it, let's do approximately. It will round to the whole number, 65. Let's look at a similar triangle word problem. On a map of a triangular piece of land, the lengths of the three sides are 5 centimeters, 6 centimeters, and 8 centimeters respectively. The shortest side of the actual piece of land is 300 meters long. Find the lengths of the other two sides. Well, first we want to draw this, and I have drawn here the smaller triangle with a side that measures 5, one that measures 6, one measures 8. Now I have an illustration of the actual piece of land, but of course it would be much larger. But when we have a map, it's drawn to scale, and so this triangle would be proportional to this triangle, which would make them similar triangles. So to find the lengths of the other sides, we will set up a proportion. I'm going to label this side side A and this side side B. The 5 corresponds to the 300, the 6 corresponds to the A. So to find A, I could say 5 is to 300 as 6 is to A. Now I know this reduces, but probably by the time I could figure out how to reduce it, I could cross multiply. So let's do that. 5 times A is 5A, and that would equal 6 times 300. So I will have 5A equals 6 times 300 is 1800. To solve this equation, I'll divide both sides by 5, and when I divide 5 into 1800, I get 360. So for the actual piece of land, side A would be 360 meters long. For side B, let's set up a different proportion. We will use 5 is to 300 as 8 is to B, because 8 and B would be corresponding sides. We will cross multiply. 5 times B is 5B, and on the other side we will have 8 times 300. 8 times 300 is 2400. We'll divide both sides by 5, and we'll get that B equals, when we divide 5 into 2400, we'll get 480 meters. So we've found that the other two sides are 360 meters and 480 meters. One thing you might check, if these are similar triangles, and since this is the smallest side or the shortest side in this little triangle, then this should be the shortest side in the larger triangle, and notice it is. The 8 is the longer side, so the B should be the longest side in the larger triangle, and notice that it is. That doesn't make it right, but that is sort of a way to check. Let's look at one last similar triangle word problem. The Island Point Lighthouse is 15 meters tall and casts a shadow 20 meters long at 7 p.m. At the same time, the shadow of the lighthouse keeper is 2 5/10 meters long. How tall is he? Well, I've sort of drawn a diagram here. this represents my lighthouse. I'm going to pretend like the sun is over here in this direction. So if it's shining on the lighthouse, then the shadow would be down on the ground like this. And it's pretty important that you realize that that represents the shadow. Now I tried to do this sort of proportionally, but this seems really small, so maybe what I'll do is I'll just redraw it. This will represent my lighthouse keeper, and then this would represent his shadow. So maybe we can see that just a little bit better. Now the shadow is lying on the ground, and we are assuming that there is a right angle created between the lighthouse and the shadow on the ground, and that there is a right angle created between the lighthouse keeper and his shadow on the ground, which we can complete this third side to create two similar right triangles. And when we label those, the lighthouse is 15 meters tall. The shadow is 20 meters for the lighthouse. And it says at the same time the shadow of the lighthouse keeper is 2.5 meters long. So this represents the shadow. So this bottom side of this triangle would be 2.5 meters. And since this represented my lighthouse keeper, I will call that side A, and that would represent the height of the lighthouse keeper, and that's what I need to find. Because these are similar triangles, I will set up a proportion using ratios of corresponding sides. The 15 corresponds to the A, the 20 corresponds to the 2 5/10. So for my proportion, I will write 15 is to A as 20 is to 2 5/10. To solve this proportion, I will cross multiply. I will say 15 times 2 5/10 equals 20 times A. When I multiply 15 times 2 5/10, I get 37 5/10 equals 20 times A. To solve for A, I'll divide both sides by 20, and I get that A equals 1 875 thousandths. Now, of course, I calculated that on my calculator, so that represents the height of the lighthouse keeper. He is 1 875 thousandths meters tall, and I just wrote it out like that because it was a terminating decimal. That completes this lesson on similar triangles and angle relationships. Please rewind the tape before you return it to the LRC so it will be ready for the next student. Thank you.